All right, problem 53 says find two quadratic functions, one that opens upward and one that opens downward, whose graphs have the given x-intercepts. And it gave us x-intercepts of -1, 0, and 3, 0. There are so many ways to get this problem done, but here's one fairly easy way. One easy way would be to figure out, okay, kind of think about factors. So if -1, 0 is an x-intercept, then I hope it makes sense that the factor x plus 1 must have been part of your rule. So that's how you would have gotten an x-intercept of -1. So hopefully that makes sense. So like that factor we know has to be part of the situation because of the 0 of -1. And then you also have a 0 of +3. So what factor would you need to have as part of the polynomial? Yeah, x minus 3 would have been another one. And then, let's see, my spacing is kind of weird. Anyway, and then you could multiply it out just to kind of show off that it is a quadratic. So just using the distribution process. So you'd have minus 3x plus x, which is -2x. And then minus 3. And so here's 1, and that one would open upward. You can tell because your leading coefficient is positive. And then another one, like x plus 1 and x minus 3 have to be factors in order for you to have these two x-intercepts. And then if you wanted to open downward, you could just put any negative number in front. So I'll just use a -1. And then that would be a parabola that has those x-intercepts and opens downwards. So you could multiply it out and then distribute the negative in. Like so. Anyway, so these would be your two answers here and here. There we go. Hopefully that helps. Let's see. Another problem that people had questions about, like problem 57. Oh, problems 57 and 59, and they're both really similar. And 59 is I'd say a little bit tougher. So I will choose to demonstrate problem 59. So the directions say find two positive real numbers whose product is a maximum. That fits the following conditions. So for 59, it said the sum such that the sum of the first number and twice the second is 24. So I suppose you could guess and check this. You could come up with a bunch of numbers that satisfy this sum requirement and then multiply them together and figure out which one has the biggest. That may or may not go quickly. So I'll show you an algebraic way to do this. So what you could do is you could just let, the first number or one of the numbers be and pick a letter. So I'm going to choose A. And then your second number be another letter like B. And then basically you have this constraint here that the sum of the first and twice the second is 24. And so just say that, but with A and B. So the sum of the first, so that's A, sum means add them together. Twice the second would be 2B, and then needs to be 24. So this is considered like a constraint equation. And then we want to maximize the product. So let's come up with a product equation. So the product would be A times B. But now let's get your product equation in terms of just one letter. And I'm actually going to move this over here. So product is equal to A times B. And then what we want to do is get this product equation in terms of just one letter. And it doesn't matter which one. So I'm going to go back to this constraint equation and isolate either A or B. And for me, I'm just going to pick A just because it looks easier. So I'm going to subtract the 2B over, like so. And then take this expression and substitute it in for A over here in the product function. And then what we'll have is we'll have the product in terms of just B. And so you're going to replace A with the quantity negative 2B plus 24. And then as you can see, I have it all in terms of B now. And so basically we're trying to figure out when is this product its biggest. And so I hope you could see if I multiply it out, if I distribute this B in, I'd get negative 2B squared plus 24B, which I hope it makes sense if you graph that, would be a parabola. So it would have a maximum value. And so, yeah, how am I going to find that maximum point of the parabola? I'm going to complete the square. So the product in terms of the second number would be, remember to factor out the leading coefficient. Oops, correctly. Leave a mysterious gap. And then remember the magic ingredient that goes there. You just divide by 2 and square the result. So let's see, divide 12 by 2, that's 6, right? Square the result, so you add 36. Now it looks like I added 36, but be careful. I actually just subtracted 72. So to undo that, I'm going to add 72 back on. So now we'll go ahead and show what it is in completed square form. So that would factor as B minus 6 quantity squared, like so. So what do I know? I know now that this parabola got shifted to the right 6 and up 72. So the coordinates of that point are 6, 72. So that means that the maximum product, first of all, is 72, because this was the value of my second number, and this is what I'd get out for the product. So the maximum product is 72 and occurs when your B value is 6. And then how could I get my A value? Well, you could just divide the 72 by 6 and get your A value. And then another nice way to get your A value would be to take B equals 6 and back substitute it right there where you knew your relationship between A and B. So if I put 6 in there, I'd have negative 2 times 6, which is negative 12, plus 24, which is 12. There we go. So the two numbers that give you the maximum product and the sum of the first is twice the second is these two numbers right here. There we go. All right, I hope that helps. I think you'll find that problem 57 is very, very similar. And feel free to ask me questions if things don't make sense.